presentation explores the software development lifecycle and its respective components regarding policy optimization within Johnathan's insurance agency. This is the agenda for this presentation. A couple of weeks ago, in a stakeholders meeting, the executives within the agency requested that the machine learning team develop a new software requirement that predicts the likelihood of customers accepting their quoted insurance policy. At the time, insurance agents could only view when a customer requested a quote, and they followed up by reaching out to the customer based on previous experience and where the customer was placed in the queue. The significance of this new software requirement would allow agents to advocate for a customer's business they are willing to lose rather than those that plan to purchase their quoted insurance policies. This change would improve business for the agency. Considering general timelines and initial business and project objectives, the machine learning team developed this software that predicts when a single customer is or is not likely to accept their quoted insurance policy. This project will be complete by May 7, 2023. From the beginning of the project lifecycle, the team implemented a hybrid approach to software development methodologies, combining both the traditional waterfall model and the agile dynamic systems development method. The integration of these two models produced the following steps for the team to follow: pre-project, foundations and requirements, feasibility and design, exploration and engineering and implementation, deployment and verification, and post-project and maintenance. This hybrid approach allowed the team to communicate effectively with stakeholders concerning goals and objectives, and to test and field different iterations as they came up. An in-depth description of the following phases can be found in the business requirements document. Transitioning into the business and technical requirements, please refer to the table presented. As you can see, each requirement is labeled with a requirement ID, which supports organization to all stakeholders involved, whether business or technical. Business requirements describe what the system must or must not do, while technical requirements describe the how of a system's functionality, which includes performance, security, usability, etc. For example, some of the business requirements include generating an inquiry application for a customer interested in receiving an insurance quote, or the system allowing the customer to create an online portal once all questions and fields from the inquiry have been answered. These requirements are the foundation of the system, while the page response time for inquiry applications or implementing the two-factor authentication for security measures are features that make the system more efficient. Before moving into the diagrams, let's discuss use cases and user stories. Comparable to business and technical requirements, use cases are sorted out as business and system use cases, otherwise known as the what and the how of a system's functionality, respectively. Use cases also include the stakeholders involved. Business use cases are communicated using business language, and system use cases detail how the system functions and are dependent on the type of technology. User stories are similar to business requirements, but they contain specific details on how a system should operate, and they are written in a specific format so that developers can build the software accordingly. Business and technical requirements, business and system use cases, and user stories work in conjunction with each other to help developers and business stakeholders understand the overall process and development of the software. On this slide are a few examples of user stories that correlate with the business and technical requirements, which are illustrated in the upcoming diagrams. Figure 1 is a business process diagram, specifically a swim lane diagram, which details the workflow of the business process. As you can see, the customer has an interest in looking for an insurance quote. He navigates to the insurance website and proceeds to fill out the required information in the inquiry application. If all required information is provided, the system will prompt the customer to create an online portal. If the customer does not provide all the required information, the system will redirect the customer back to the inquiry application to finalize any missing details. Once the customer portal is created, the machine learning software will validate the customer's information, starting with his credit score and ending with asking about the likelihood of whether the customer will accept an insurance quote today. The customers will be placed in their respective pools based on the analyzed information. For customers that do not intend on accepting an insurance quote, but are potential customers, insurance agents will be notified to fight for their business. Figure 2 is the project management timeline for the engineering and implementation phase. Referring back to the business and technical requirements, the team began testing and building prototypes on April 3rd. Each task was completed within 2 hours before proceeding to the next task, totaling about a 10-hour workday each day for a 5-day sprint. This diagram is detailed with task name, duration, and the start and end dates so that all stakeholders can hold each other accountable. Figure 3 illustrates the use case. The two actors involved include the customer and the insurance agent. Both actors can access the insurance website and view the inquiry application. However, only the insurance agent has access to view the likelihood of the customer accepting the insurance quote, similar to the business process diagram. Since the overall business goal is to validate whether the customer will accept the quoted policy, the customer does not receive any notifications in return. Figure 4 is a sequence diagram, which details the interactions and potential messages between the objects, indicated by the lifelines. For this diagram, the sequence of events mirrors the business process diagram, displayed in another format. The customer interacts with the website, completes the inquiry application, creates a customer portal, and the machine learning software validates the customer's information. The class diagram depicts the relationship between the actors, the software, and the processes that ultimately lead to the creation of the software that finds the likelihood of a customer accepting a quoted insurance policy. The classes include attributes and methods that detail what developers need to include in the requested software. The data flow diagram illustrates how the collected data moves from the customer to the system and finally to the insurance agent. This diagram shows the processes and subprocesses involved, as well as inputs and outputs of the data. As you can see, the quote details flow to the customer and review data stores, as well as to the machine learning software for validation. Once the information is reviewed, the insurance agent is notified of quote acceptance likelihood so that the agent can compete for the customer's business. Finally, the data dictionary connects the respective objects, elements, and variables together by similar descriptions, which communicates the content of the data to applicable stakeholders. For example, if a stakeholder did not understand register date, he can refer to the interpretation included in the data dictionary for clarification. Along with a short description, the data dictionary also includes the data type, the length of each data type, ID number, and primary roles. Considering the overall project and the machine learning software, the team must consider the concerns and potential solutions to mitigate any associated risk. First, due to the iterative nature of software development and multiple teams working in their respective phases, a concern is supporting effective documentation. A potential solution is supporting version control so that all stakeholders understand the progress of a specific requirement, preventing the repeat of a task already completed. Subsequently, another related concern regarding iterations is being open to vulnerabilities due to unpatched software and lack of firewalls and security measures. A potential solution is mandating information systems security training and ensuring that all software patches are complete before moving on to the next requirement. Third, scalability is a concern regarding a potential system crash if an influx of users floods the site past the dedicated threshold. This concern also includes supporting page response time despite the number of users accessing the website. To fix this concern, a solution could include programming code into the system to redirect users to a separate queue once the website reaches a 5-user threshold. Currently, the machine learning team will continue to meet with stakeholders to wrap up any remaining details and answer further questions and concerns. I appreciate your time, and I look forward to your responses.